Hi kids. All right, I'm going to do a problem for you where our problem is to find the magnetic field directly in between the wires. So I have two parallel wires, currents both going the same way. I have a black wire here. The current is going 5 amps going straight up or to the top of the page, and I also have a wire here where the current is 3 amps going to the top of the page. And we want to find the magnetic field directly in between them. All right, magnetic field is a vector. That, of course, means that you have to find how big it is and the direction of the magnetic field. So if you're going to do this with me, I would recommend that you guys get two colors. But if we do this, if we do the right-hand rule for this one, on this side, the magnetic field for the red one is going into the board. On the other side, the magnetic field is coming out of the board. And again, that means it's going out of the board every place over here. It's going into the board every place over there. For the black wire, it's going into the board on this side and out of the board on the other side. All right, so if you guys take a look though, I'm asking you to find the magnetic field directly in between them. So really, this is what I'm concerned about. I could ask you to find the magnetic field over here. If I was doing that, then I would have red X's and I would have black X's because the magnetic field on the right side of the black wire is going into the board. I could ask you to find the magnetic field on this side. If I was doing that, I would have black dots and I would have red dots. But keep in mind, guys, that the magnetic field is not always going to be the same. You have to do your right-hand rule. And be sure you're using your right hand. Okay, so I'm not going to worry about this or this. I'm just worrying about directly in between them. All right, if you look, though, because they're pointing opposite directions, after we find out how big they are, we're going to have to subtract them because they're going opposite ways. So I need to find out how big they are. So I'm going to use one of my B field equations. The one that I need to use is for a long straight wire, which is that equation right there. So I'm going to do the black wire first, and let's use the appropriate colors here. So I'm going to get B equals mu naught, which is 4 pi times 10 to the minus 7th times 5 divided by 2 pi times, if I'm halfway between, that's 15 centimeters, but I have to change that to meters. So 0.15 meters. If I do the math there, I'm going to get 6.67 times 10 to the minus 6 Teslas, and that is going into the page. Okay, it's a vector, so you need to know how big it is and the direction. For the red one, my formula is going to be 4 pi times 10 to the minus 7th times 3 divided by 2 pi times 0.15 again. If you do the math there, you would get 4 times 10 to the minus 6 Teslas, and that is pointing out of the page. Okay, now I have to figure out my net magnetic field because they're going opposite directions. I'm going to take the bigger one minus the smaller one. So my magnetic field is going to be equal to that magnetic field minus that magnetic field. So this one minus that. If I do the math there, I am going to get 2.67 times 10 to the minus 6 Teslas, and the direction would be, because this one is bigger, the direction is into the board. So bam, 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 we are done. Bye, kids.